Alright, so this will be the end of section 3.5. It's going to be another long video. I guess this is part 4 of section 3.5. And let me just kind of jump into it. The next 4 problems have us make graphs, and these are a bit easier than the last problem, so let me just kind of jump into it. This is your problem 21. You're probably not ready to do that. Let me start with 22, and I'll flash 21 back up on the screen. So problem 22 gives me the function f of x equals the absolute value of x that we've worked with a bunch. Wants me to sketch a graph of that. And real quickly, I'll just sketch a graph of that. I'll do it in blue this morning. So I'll have the graph of x and f of x. And for that absolute value graph, we did the table that had -2, -1, 0, 1, 2 in the x column. Take the absolute value of all these numbers and get +2, +1, 0, and 1, and 2 in the y column. So just real quickly, I'll plot those points. And make my V. I don't have my ruler out this morning. So this is just the generic V that is the absolute value of x graph. I've done a bunch of times in this section already. For part B, I want to do 2 times the graph. I want to find 2 times the f of x. And 2 times f of x is really nice to find, since f of x is equal to the absolute value of x, and because the 2 is not in the inside the parentheses with the x, to find 2 times f of x, I'm just going to multiply 2 times the absolute value of x, and it's just going to be right in front of the absolute value symbol. That 2 would have to be inside the parentheses for it to go under the absolute value symbol with the x. The nice thing about this problem is that anytime the change is after the function or in front of the function, when we go to make a table of values, we can use the same x column. So as I go to graph this function, my table of values can be the same. I'll do this in red. So I'm going to make an x and a 2f of x table. And my x's for this can be exactly the same. If there's a number inside a parentheses in the transformation, then I can't use the same table. But because the number 2 is in front of the parentheses, I can use the same x values. So let me go ahead and enter this and get my y's. Very specifically, I'm going to enter 2 times the absolute value of x. So I'm going to go y equals clear 2, then math, over the number, hit enter on absolute value, my x. I'm going to hit zoom standard just in case my window is kind of not good. Let me get my table. So second table, next to -2 I see +4, next to -1 I see +2, next to 0 I see 0, 1, 2, and 2, 4. So I'm just going to plot those points. So I'll plot the point -2, +4, -1, +2, 0, 0, 1, 2, and 2, 4. I'm going to get a narrower graph. Usually multiplying by a number bigger than 1 makes the graph narrow. Multiplying by a fraction in between 0 and 1 generally makes the graph wider. When I looked at this problem, immediately I knew the graph was going to get narrow, because generally when you're multiplying by a number in front of a function, if the number is bigger than 1, it makes the graph get skinny. If the number is a fraction between 0 and 1, it makes the graph get wide. So I've done part A. I sketched a graph of the f of x equal to absolute value of x. I did part B. I found the function I needed to find, and I did part C. I made a table of values and sketch a graph. Now I need to do part D, and I need to describe the transformation. Quite honestly, if you just said it gets narrower, I would be completely content with that, because that's what I think. When I look at a function And if I'm multiplying by a number bigger than 1, I know the graph's going to get narrower as opposed to wider. The appropriate thing to say from my table, I've updated the table recently here. So this fits in this part of the table. This is the function a times f of x, where the a is 2. And when the a is bigger than 1, the appropriate thing to say is that the graph gets stretched as opposed to gets made narrower. So what I could have said is that the graph gets stretched. I live with either one of those answers. I generally don't ask stretching and compressing questions on the test, so it's not the biggest deal if we don't quite know the right words to use there in the answer. But the important thing is to realize that if there's a number that you're multiplying by in front of a function, if that number is bigger than 1, it's going to make the graph narrower. If it's a fraction between 0 and 1, it's going to make the graph wider. When I do part E, I expect the graph to get wider. When I go down to describe this graph, because first I'm going to find this function, I'm going to make a table of values and sketch the graph, and then I'm going to describe the transformation. I already think that the graph's going to get wider or fatter because the number in front of the function is between 0 and 1. So when we go to part E, the original function is f of x equals the absolute value of x. To find each function, because the 1/2 is in front of the f of x, I can't put the 1/2 inside the absolute value. I'll put it in front of the absolute value. And this is actually going to be my answer to part E. To find each function, I'm just finding the function 1/2 times the absolute value of x. I'm going to do part F on my graph screen. When I go to graph this function, I could use the same table that I used for the absolute value of x because the number that I'm multiplying by is not inside the parentheses. Right at the end of the last video, I either had to divide or multiply by a number to get change my x column, but here I don't have to. So when I go to do part, I should get another color. When I go to do part F, graphing this function, I'm going to make a table that has x and 1/2 f of x, which is really 1/2 the absolute value of x. And I'm going to use the same -2, -1, 0, 1, 2 starting table. I'm going to enter this on my calculator to get the y's. I'm going to clear out the function that's in there. I'm going to go 1/2 times the absolute value of x. And to be safe, I'm going to put the 1/2 in a parentheses. And then I need the absolute value of x, so math number absolute value in x. So there's 1/2 absolute value of x. It's going to be a really wide graph. And now when I go second table, I'm going to get the point -2, +1, -1, +0.5, 0, 0, 1.5, and 2 and 1, and I'm going to plot those the best I can. So the point -2, +1, the point -1, +1/2, 0, 0, 1 and 0.5, and 2 and 1 give me a really wide V. So I'm kind of doing multiple graphs on the same graph. So as I go to answer this part F, I'm just going to say see the graph because I made my table and my graph on the other sheet of paper. And when I go to describe this graph, I love to just say that it just made the graph wider because it compared to the blue graph with the absolute value of x, this one's wider. So that's a really nice thing to say. The text on our campus would say that instead of using the word wider, it would say that it compresses the graph. So let me just put that in because you can use that for an answer as well. Oh, right. So that's the end of problem 22. So I made my tables of values, sketch the graph, describe the transformations for the functions that I needed to do. So you should give a shot for 21. and work through all that with your function 3f of x and 1/3 f of x. You might also be able to do problem 23, which would be great, and if you can't, that's okay. I'll flash 23 back up after I do 24, just in case you don't know how to do 23 just from looking at what I just showed up there. So for problem 24, it starts off and it asks me in part A to graph the function f of x equals x squared, which we've done a bunch. So to do part A, I'm not going to describe it. I'm just going to jump in and graph that function f of x. The table that we use for that has -2, -1, 0, 1, and 2 in the x column. And my y's are 4, 1, 0, 1, and 4. If I just plot those points, -2, +4, -1, 1, 0, 0, 1, 1, and 2, 4, I get just a generic parabola. Done with part A, moving on to part B. Part B, I start off with the function f of x equals x squared, and I'm asked to find 2 times the function f of x. To do that, I just multiply 2 by the x squared, and I don't need to put the 2 in a parentheses because it's not inside the parentheses with the x. So my answer for part B is that this would just be the function 2 times f of x. Part C wants me to make a table of values and sketch a graph. And then part D wants me to describe the transformation. I know for certain that this graph is going to get narrower or skinnier because if I multiply by a number bigger than 1, it's going to make the graph get narrow. So let me show you that by making my table of values, cheating and using my calculator the best I can. So my next table, I'm going to have x and 2 times f of x. In my x column, I'm going to use the same x's, -2, -1, 0, 1, and 2. And then for my y's, I'm going to use my calculator. So I'm going to go y equals clear 2x squared, and then graph it, and then steal my table. So second table, next to -2, I see 8. Next to -1, I see 2. Next to 0, I see 0. Next to 1, I see 2. And next to 2, I see 8. So I'm going to plot those points and expect to get a skinny graph. So -2, +8, -1, +2, 0, 0, 1, 2, and 2, 8. When I plot those points, I get a real narrow or a narrower parabola. So when I described in part D saying the graph is narrower, I like that word. The other choice I could have said is I could have said the graph was stretched. So if you're multiplying by a number in front of a function notation, if that number is bigger than 1, it's going to make the graph narrower or it's going to stretch the graph. If you're multiplying by a number between 0 and 1, it's going to make the graph wider or compress the graph. So for my answer to part D, to describe what happens for the function 2f of x, I can use either the word the graph gets narrower, or I can say the graph is stretched. The next part wants me to find 1/2 f of x. And when I describe the transformation, anytime I multiply by a number that's in between 0 and 1, I expect my graph to get wider. So that's what I'm going to say in my answer, and then I'll use a word from my table here in a second. So to find the function 1/2 f of x, easy enough. The original function is f of x equals the absolute value of x. 1/2 f of x is just going to be 1/2 times the absolute value of x. To make my table of values and sketch a graph, I'm going to go on the other sheet. I can use exactly the same table. So when I go to graph x and 1/2 f of x, I'm going to use the x's of -2, -1, 0, 1, and 2. I'm going to use my calculator to get the y's. On my calculator, I'm going to go parentheses 1 divided by 2, and then x squared. Make my graph, it's going to be a wide graph compared to the last two. And then second table, next to -2, I see 2. Next to -1, I see 0.5. Next to 0, I see 0, 1.5, and 2 and 2. So let me plot those points real quickly. So -2, 2, -1, 1/2, 0, 0, 1, 1/2, and +2, 2. And the best I can, I'll draw a U through those points, or a parabola through those points. And it made the graph wider as opposed to narrower. So my answer, when I snuck an answer in prematurely for part G to describe the transformation, that makes it wider. And we can use the word compresses instead of wider if we want. If we're multiplying by a number in between 0 and 1, the proper thing to say is the graph gets compressed. But for me, I just generally think wider as opposed to compress. And that would be, the answer that I would come up with. So I'm going to pause the video here and then finish up this section without making another part, because this hasn't been that long. So we'll just keep going. I was supposed to flash your 23 back up here, so there's your problem 23. Get that done. This might actually be a good stopping point. The problems get a little bit different once we get beyond 23 and 24, but I think they're easier. Alright, so this will be the end of section 3.5, and a lot of the problems should go pretty quick as long as we understand what we learned at the beginning of this section. Real specifically, we have to remember that f of x plus h with an h in a parentheses will move a graph left h units, for what that's worth. And f of x minus h will move a graph right. And then f of x plus h with the h not in a parentheses will move a graph or shift a graph up. F of x minus h with the h not in the parentheses, I think I used k earlier, but the letter there is irrelevant, will move a graph down. F of negative x flips a graph or reflects a graph over the y-axis. And negative f of x reflects a graph over the x-axis. I think that's what we need to finish up this group of problems. We might have the compressing and stretching stuff, and if we need that, I'll add that as it's needed to this little list. So in each of the problems between 25 and 50, we're going to take the function f of x equals x squared, and we're going to create a function that has the same graph but is shifted in a certain direction. And for problem 26, I need to create a graph that has the same shape as f of x equals x squared, but it needs to be shifted to the left 3 units. To shift a graph to the left 3 units, I know that that has to be, the graph I'm going to find is going to be f of x plus 3, because f of x plus 3 with the plus 3 in the parentheses is going to shift the graph left. I'm trying to create a graph that's going to be the same shape as f of x equals x squared, but move to the left. And f of x plus 3, with if the plus is in a parentheses, to find that function, the x plus 3 is going to need to go in a parentheses. The answer to problem 26 is just f of x plus 3 is x plus 3 squared. This is the graph. This equation would have the same graph of f of x equals x squared, but it would be moved 3 to the left. If the graph of f of x equals x squared is a parabola with a vertex at the origin, this graph would be a parabola with a vertex at the point negative 3, 0. It's going to be exactly the same shape. It's just going to be shifted 3 to the left. For problem 28, I need to create a graph that's the same as f of x equals to x squared, but it's shifted to the right 4 units. And to shift a graph to the right 4 units, I need to do a minus inside of parentheses. So the function notation to shift a graph to the right 4 units is f of x minus 4 with the minus 4 in the parentheses. And in terms of related to the f of x function that I'm given, that's going to be the function x minus 4 in parentheses squared. 29 and 30 want me to do reflecting over the x and y axis. I'll do them both. For 29, because the negatives for 29, because it wants me to reflect over the x-axis, I just need to do negative f of x. I just need to put a negative in front of the f of x symbol. So the original function is f of x equal to x squared. To reflect a graph over the x-axis, you need to do negative f of x. And negative f of x is just going to equal negative x squared. If you want to, you can consider this as negative 1 times f of x and write that as negative 1 times x squared. These are both correct answers for problem 29. Both of these graphs, if I graphed them on my calculator, would look identical to each other, and both of them would be the same as a graph of x squared, but flipped over the x-axis. So let me just show you real quickly that all of these will graph the same. So I'll show you the reflection real quickly here, doing f of x equals x squared. So x squared is that function. And if I do negative x squared, negative without a parenthesis, y equals negative x squared, it's going to produce a graph that's reflected over the x-axis. If I clear that out and then graph y equals negative 1x squared, I'll still get that same reflection over the x-axis. So both of these are correct versions for problem 29. For problem 30, I need to create an equation that's reflected over the y-axis. And to reflect a graph over the y-axis, the negative x that causes that reflection needs to be in a parentheses. So my answer for problem 30, the original function is f of x equals x squared. The function that's going to be reflected over the y-axis is f of negative x, which would be negative x squared. So this would be a correct answer for number 30. And of course, it would be okay if you wrote negative x squared as just positive x squared, because negative x squared means negative x times negative x, and that's positive x squared. So this would also be a correct answer for problem 30. All right, so hopefully you can skip through and do 25, 27, and 29 on this page. I'll move on to my next page where I have a bunch of more shiftings. So each one of these functions, I want to create a function that looks like f of x equal to x squared, but it's just moved the way it's described. And in problem 32, I want to move a graph up. To move a graph up, you need to add something after the function. And for my answer to problem 32, the function I'm going to need to create needs to be the function f of x plus 3. And if the plus 3 was in a parentheses, it would move the graph left. Since the plus, I want to move the graph up, I put the plus 3 after the function notation. And then to find out what that function is, I just add 3 after the x squared. This is going to be my answer to 32. For 36, I want to take the graph of f of x equal to x squared and move it down 6 units. And to move a graph down, I subtract a number after the function notation. So to move a graph down 6 units, I'm going to do f of x minus 6. And that's going to equal x squared minus 6. That's going to be my answer to problem 34. For problem 36, I need to move a graph right 3 units. To move a graph to the right 3 units, I need to put a minus in a parentheses. So for this piece right here, I'm going to need to move the graph of f of x equals x squared to the right 3 units, I'm going to need an x minus 3 inside of parentheses in my function notation. And then to move the graph down, I'm going to need a minus after the function notation. So this combination, f of x minus 3 minus 4, will move the graph right 3 and down 4. Now I just need to transform this into something that has the x squared, and the x minus 3, because it's in a parentheses, is going to go in place of that x inside a parentheses. The minus 4, because it's after the function, is going to go after the parentheses. And this would be my answer to problem 36. Real specifically, if I graph these, if I graph the original function x squared, you have that nice parabola at the with the vertex at the origin. This is going to take the graph and move it over 3 and down 4. So it's going to move it down here somewheres. So if I go y equals and graph what I created here, parentheses x minus 3 squared minus 4, what I'm going to get is a parabola that looks exactly like the original parabola, but it's shifted left 3 and down 4. And these two parabolas, if you slid them into each other, they should fit perfectly. It's kind of hard to see when you start moving parabolas that they fit perfectly into each other because they start getting wider. If you drug this graph down and over, they'd fit perfectly. They'd be exact copies of each other. All right, so if you haven't already, try 31, 33, and 35. All right, so to do 38, to do a graph that's shifted to the left 3 units, I need to have a plus inside of parentheses. To move a graph down 4 units, I need a minus inside of parentheses. So generically, the function f of x plus 3 minus 4 with the x plus 3 in a parentheses and a minus 4 outside the parentheses will take the graph of f of x and move it to the left 3 units and down 4 units. To create a function that does that to the parabola x squared, I'm going to take the x plus 3 and put it in a parentheses because it's in a parentheses in place of that x with an exponent of 2, and I'll put the minus 4 after the function, or after the parentheses. So that would be my answer to 38. For 40, to shift a graph to the right 3 units, I need a minus 3 inside the parentheses of the function notation. To move a graph up 4, I need a plus 4 after the function notation. So this generically would move the graph of any f of x function to the right 3 units and up 4 units. To create a function that will do that to the parabola x squared, I need to do this transformation with the x squared. Specifically, I'm going to change the x to an x minus 3 in a parentheses and leave the squared outside the parentheses, and the plus 4 is going to go after the squared, or after the parentheses. This would be my answer to problem 40. For problem 42, to shift a graph to the left 3 units, I need a plus 3 inside the parentheses with the function notation. To move a graph up 4 units, I need a plus 4 after the function notation. That generically would take any f of x function and move it left 3 and up 4. Now if I want to take the graph of f of x equal to x squared and do that, I have to create the function x plus 3 squared plus 4, and that will move the graph left 3 and up 4. That'll be my answer to 42. If you haven't already, hopefully you can do 37, 39, and 41. I'll move on to the next page. Just in case you need to glance at this again, these are all the movements that we're doing. The shiftings left and rights are with using parentheses. The ups and downs, I don't need parentheses to do that. And the reflections, I need negatives in the right place. For problem 44, to reflect a graph over the x-axis, I need a negative in front of the function notation. So to get this function-wise, I get negative f of x. That's going to take the graph of f of x and flip it over the x-axis. And now I want to move it up 3 units, and to move it up 3 units, I get a plus after the function. So this generically would take any f of x function, flip it over the x-axis, and move it up 3. Our f of x function is x squared. To flip it over the x-axis and move it up 3, I can just put a negative in front of the x squared, or I could put a negative 1 in front of the x squared and put a plus 3 afterwards. I don't get any parentheses in this transformation because the parentheses between the original problem and the transformation are the same. It also would have been okay if to the right of the equal sign, if I wrote negative 1x squared plus 3. And what this will do is it will take the graph that is generically a parabola with a vertex at the origin. It'll first flip it over and then move it up to up 3. So what it's going to do is create a graph that looks like that. It's going to be flipped over because of the negative in front of the x squared, and then after it's flipped over, it's going to be drug up 3. Let me just show you that pictorially in case you want to see that. So if I graph the function negative x squared plus 3, first there's the f of x equals to x squared, then there's a graph that's flipped over and moved up 3, just kind of like I sketched there. For problem 46, to reflect a graph over an x-axis, the equation needs to have a negative f of x. To move a graph down, I get a minus 4 after my parentheses, or after the function notation. And that will take any graph of the function f of x and reflect it over the x-axis and move it down 4 units. Specifically for this f function, the function that I need to write in my answer is going to be negative x squared minus 4. That would be my answer to 46. For problem 48, I want to reflect it over the x-axis. That would be negative f of x. And then I need to go right 2. And to get it to the right 2, I have to put a minus inside the parentheses. Actually, I need a minus 2 inside the parentheses. So this equation, f of x minus 2, will take any function f of x, reflect it over the x-axis, and move it to the right 2. The original function that I'm reflecting over the x-axis and moving right 2 is f of x equal to x squared. For this, I'm going to have an x minus 2 inside of parentheses to move the graph to the right 2. If I put the negative inside the parentheses in front of the x, it's going to reflect it over the y-axis. To reflect a graph over the x-axis, the negative needs to go outside of parentheses or in front of the function if there's no parentheses. So that should take the graph of f of x equal to x squared, flip it over, and move it to the right 2. So what this graph should look like, it's going to be flipped over and then drug to the right 2. This graph, if I graph it, it's going to look like that. It's going to have a vertex at the point 2, 0 because the vertex got moved from the point 0, 0, right 2 to 2, 0, and it gets flipped upside down. Let me show you that. Not that you maybe even care to see that, but if I do y equals clear negative parentheses x minus 2 squared, if I graph that, I'm going to get this graph right here. It's shifted to the right 2 and it's flipped over the x-axis. So go ahead and give 43, 45, and 47 a go. And then we only have one more problem each in this section, and then there's another group of problems that we have to deal with. Okay, so on problem 50, I need to reflect over the x-axis, so I get a negative f of x. And then I have to go left 4, and to go left 4, I need a plus inside of parentheses. This will take any f of x function, that will reflect it over the x-axis, that will move it left 4. And to do that to the function f of x equal to x squared, I'm going to need an x plus 4 inside the parentheses, because the x plus 4 is inside the parentheses, and a minus in front of the parentheses. And that will be my answer to problem 50. All right, so for the next few problems, we're given a graph of some absolute value function that's called f of x. So this is, for your problem 51, this is the graph of a generic f of x function, and we're asked to graph each of these functions and to describe the transformation. We're not actually asked to create the function because I don't know the exact equation that made this graph, but without knowing the equation that made the graph, I can look at the function notation and describe the transformation, and I can make a graph that does that transformation. So let me, I'll flash this up in a bit, but let me do a few problems so that you might have a chance to do these. So for problem 52, I think it's exactly the same graph. Not exactly the same graph. And I probably should have labeled the point 3, -5, because that's going to be an important point. So I'm going to, in problem 52, I'm going to sketch a graph for part A of f of x minus 3. And I know that this, if I want to describe what it's going to do to the graph of f of x, it's going to shift it to the right 3 units, or move to the right 3. So to do this graph, so I'm supposed to describe the transformation and sketch a graph. To do this graph, all I need to do is take every point and move it to the right 3. So this point, I'm going to go 1, 2, 3 to the right, make a dot. This point, I'm going to go 1, 2, 3 to the right, make a dot. This point, 1, 2, 3 to the right, make a dot. This point, 1, 2, 3 to the right, make a dot. That point, 1, 2, 3 to the right, make a dot. This point, 1, 2, 3 to the right, make a dot. And I'm going to just make the exact same shape, which is just a v, which is like some absolute value function. And this is how I'm going to move my graphs for this group of problems. So I created a graph that's the same as the graph that's given, but it's shifted to the right 3 units. If you took my graph and moved it, you can get it to fit right on the original graph. For part B, I need to describe the transformation, what f of x plus 4 does. Because that plus 4 is in a parentheses, it's going to move it to the left 4 units. Inside the parentheses, pluses are left, minuses are right. That's what this says up here. Inside parentheses, pluses are left, minuses are right. After the function notation, pluses are up and minuses are down. Now I'm going to create a graph on this same graph, taking every point and moving it to the left 4 units to graph f of x plus 4. So I'll take the little v point here and move it 1, 2, 3, 4 to the left, and then this point go 1, 2, 3, 4 to the left. This point 1, 2, 3, 4 to the left. This point 1, 2, 3, 4 to the left. This point 1, 2, 3, 4 to the left, and that point 1, 2, 3, 4 to the left. So I just took all the points on the given function that was given to me in problem 52. I took each point and I moved it to the left 4 units. And now I'm just going to draw exactly the same shape because this is a rigid transformation. All this transformation does is it moves each point, but it doesn't distort the shape. The shape's exactly the same V. So those would be an answers for both 51 and 52. You might be able to do part A and part B of your 51. You might even be able to do them all. Now I'm going to move on to part C of 52. I'm going to describe how this is going to move the graph of f of x, and how this is going to move the graph of f of x because it's a minus outside or after the function notation. It's going to move a graph down 3. And now I need to take every point and move it down 3. So at this point I'll go down 1, 2, 3. This point 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 down 1, 2, 3, and that point down 1, 2, 3. And I'm going to sketch a graph of f of x minus 3, color-coded in red. So if you're doing multiple graphs on the same graph, you could color code so I can tell which one is which, or you could just write next to this graph, I can just say this is f of x minus 3. The next graph, f of x plus 4, I need to shift the graph up 4. And so I'm going to take each point and move them up 4. So 1, 2, 3, 4 up, 1, 2, 3, 4 up, 1, 2, 3, 4 up. I have to do the little point, so 1, 2, 3, 4 up, 1, 2, 3, 4 up, and 1, 2, 3, 4 up. I'm waiting for my video to have a hiccup, but it's just not doing it. So now I'm just going to make that exact same V shape. I don't necessarily care on your homework if you're using graph paper or not, nor do I particularly care if your graphs are, stellarly perfect. It just as long as they seem reasonable. All right, so back to do parts C and D. There's my break. That might inspire you to do part C and D of 51. And again, you might be able to do all of problem 51, which would be kind of nice if you could. For problem 52, part E, to describe the transformation, a minus inside the parentheses is going to move a graph right. The plus after the function notation is going to move a graph up. I don't know why I just made that one the blue one, but I did. So now I'm going to take each point and move it right 3 and up 4. So this point right here, I go right 1, 2, 3, and up 1, 2, 3, 4. It's going to move to there. This point I go right 1, 2, 3, up 1, 2, 3, 4. This point right 1, 2, 3, up 1, 2, 3, 4. This point right 1, 2, 3, up 1, 2, 3, 4. This point right 1, 2, 3, up 1, 2, 3, 4. And this point right 1, 2, 3, up 1, 2, 3, 4. And make my V. Every single point should lie on one side of the V or another. So this is my graph of f of x minus 3 plus 4. All right, and for 52, for f of x plus 4 minus 3, the plus 4 inside the parentheses is going to move the graph left 4, and the minus 3 is going to move it down 3. If you want to be more efficient, you don't need to move every single point. If you just move the point at the tip of the V and then one point on either side of the V, that will give you a good enough graph rather than moving every point. And I'm going to do that here. I'm just going to move 3 points to get my graph. I'm going to move this point left 1, 2, 3, 4, and down 3. So any point to the left of the V, you could just move one of them. The point at the peak of the V, I need to move. And then any point to the right of the V. I'll do this point left, 1, 2, 3, 4, down 1, 2, 3. I mean, there's a danger in doing that. There's a danger that you move one of the points wrong. Moving every point, if you get a point that doesn't fit on a line, then you know you've made a mistake. But if you want to be efficient with these movements, then just move 3 points, 1 point on either side of the V, and then the point at the V itself, just to save some time. All right, so that should inspire you, hopefully, to do 51E and F. Pause the video if you want to get that done. And now 52G, it's f of negative x. That's going to reflect the graph over the y-axis. I need to take each point and move it to the opposite side of the y-axis, make it at the same distance from the y-axis. So this one right here, I'm going to say this is going to reflect over the y-axis. And I'm going to take the v, which is down at -5 and 3 to the right of the y-axis. I'm going to move it 3 to the left of the y-axis. So there's 1, 2, 3. I took this point and moved it to the opposite side of the y-axis. This point right here, that's 2 to the right of the y-axis. I'm going to move it 2 to the left of the y-axis. This point that's 6 to the right of the y-axis, I'm going to move it to 6 to the left of the y-axis. This point that's on the y-axis is going to stay on the y-axis. This point that's 8 to the right of the y-axis is going to go 8 to the left of the y-axis. This point that's 2 to the left of the x-axis is going to go 2 to the right of the x-axis. So you just take each point, basically change the sign of its x. This point negative 2, 0 went to the point positive 2, 0. This point positive 8, 0 went to the point negative 8, 0. This point 0, negative 2 stayed at 0, negative 2. This point 2, negative 4 went to negative 2, negative 4. You're going to get exactly that same v. Doing rigid transformations, shifting your graph left, right, up, and down will give you an exact copy of the graph just in a different location. So the graphs would actually fit perfectly on top of each other. So this is my graph of f of negative x. And for part h, the negative in front of the function notation is going to reflect the graph over the y-axis, over the x-axis, should I say. And so I need to take each point and move it to the opposite side of the x-axis. This point right here is 5 beneath the x-axis. It has an x-coordinate of negative 5. It's going to wind up having a y-coordinate of positive 5. It's going to move from 5 below the x-axis to 5 above the x-axis. This point that's 2 below the x-axis is going to move to 2 above the x-axis. This point that's on the x-axis will stay on the x-axis. This point that's 2 below the x-axis will go 2 above the x-axis. Point on the x-axis will stay on the x-axis. I think this will make a perfect graph. I'll just connect these points with the v now. You can tell if you move all the points, and if you get a point that doesn't lie on the v, then you've made a mistake with one of those points. And this is negative f of x. Alright, so that's everything for 52. Let me flash 51 up here just in case you need to see it again. And then I'll flash 53 up. You need to do the same thing with 53 that you did with 51. For the first graph, for part A, you're going to need to move it to the right 1 unit. And I just need to take each point and move it to the right 1 unit. So the vertex, I'd move it to the right 1 unit. Each one of these points, I'd move to the right 1 unit. And this point, I'd move to the right 1 unit. Can't draw this with a ruler because it's not a straight line. And this would be a decent graph for 53 part A. I took that graph and I shifted it to the right 1 unit. So for each of yours, parts B, C, D, E, F, G, and H, you need to describe what happens to the graph. For part B, you'd say it moves it to the left 2, and then do a graph move to the left 2. If you don't show every graph, it's not going to hurt my feelings. Like if you described all the transformations, it just maybe did the graphs of A, C, E, and G, or B, D, F, and H, just like 3 or 4 of them, that will be fine. I think, if you can do 2 of the graphs, you probably can do them all, and doing them all seems like overkill. All right, so let me work through, and I won't flash problem 53 up again. So if you need to do 53, try to get it done now. You might have to rewind if you aren't ready to do it. So for 54a, the minus inside the parentheses will move this graph to the right 5. So I'm going to take each point and move it 1, 2, 3, 4, 5 to the right. So this one, 1, 2, 3, 4, 5 to the right. This one, 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 to the right. And then 1, 2, 3, 4, 5 to the right. This will be, for my horrible ability, a graph of f of x minus 5. For part B, that's going to move the graph to the left 4. So I'll take each one of these points and drag them 1, 2, 3, 4 to the left. 1, 2, 3, 4 to the left. 1, 2, 3, 4 to the left, 1, 2, 3, 4 to the left. And then 1, 2, 3, 4 to the left. 1, 2, 3, 4 to the left. And that's my graph of f of x plus 4. Maybe I'll stop doing every single graph just because I said you can stop doing every single graph because it gets kind of silly. There's not that hard to do these. For part C, the minus after the function is going to move the graph down. So this is going to shift the graph down 5. For part D, the plus after the function is going to move the graph up 4. The important thing is to be able to look at the function notation and describe how that moves the graph, because moving the graph isn't that hard to do. And I'm only going to graph D, I'm not going to graph C. Just like when you're doing your homework, maybe don't do every graph. So I'm going to take every point and move it up 4. So up 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and get something like that is shifted up 4. It's so much harder to see with parabolas, the shifting, than it is the absolute values. Just in case you need to look at 53 again, I saved it so you can look at it. For 54 part E, this minus is going to move the graph right 5 because it's in a parenthesis. That plus 4 is going to move the graph up 4. For 54F, the plus is going to move the graph left 4, and the minus there is going to move the graph down 5. Inside a parenthesis, plus is left, minus is right. After the function notation, plus is up, minus is down. Let me just graph one of these. Let me graph part F. So this is what I'm going to graph. So I'm going to move left 4 and down 5. So this point I go left 1, 2, 3, 4, and then down 1, 2, 3, 4, 5. This point left 1, 2, 3, 4, and down 1, 2, 3, 4, 5. This point left 1, 2, 3, 4, down 1, 2, 3, 4, 5. This point 1, 2, 3, 4 to the left and down 1, 2, 3, 4, 5. And then lastly 1, 2, 3, 4, 1, 2, 3, 4, 5. So this is a graph of f of x plus 4 minus 5. Again, I just take every point and I move each point exactly the direction that I'm told to move. In this case, I went left 4 and down 5. If I was to graph that one, I would have taken each point and moved it to the right 5 and up 4. (54G), because it's f of negative x, it's going to reflect it over the y-axis. Because the negative's inside the parentheses, it reflects over the y-axis. For 54H, because the negative's in front of the function notation, it's going to reflect the graph over the x-axis. When you reflect it over the y-axis, you're not going to see a darn thing because this graph has symmetry to the y-axis. So let me do 54G. Any point on the y-axis is going to stay on the y-axis. This point right here that's 2 to the left of the x-axis is going to move to that point that's 2 to the right of the x-axis, y-axis. This point that's 2 to the left of the y-axis is going to move back to this point that's 2 to the left of the y-axis. This point that's 3 to the left of the y-axis needs to move to that point that's 3 to the right of the y-axis. This point that's 3 to the right of the y-axis moves to that point that's 3 to the left of the y-axis. Each point, because they're equidistant from the y-axis, moves to its kind of image point, or its point on the opposite side of the y-axis. So this is the graph of f of negative x. To do the graph of negative f of x, I'm going to take each point and flip it over the x-axis. The vertex that was 5 above the x-axis is going to go to 5 below the x-axis. These 2 points that are 1 above the x-axis are going to move to 1 below the x-axis. These 2 points that are 4 below the x-axis are going to move to 4 above the x-axis. And then I'm going to get that for my graph of negative f of x. It's nice when you use colors. It just makes it a little bit easier to follow the graphs. just in case you need to see 53, I saved it. And then 55 you might be able to do just fine. Maybe you can, maybe you can't. So do as much of 55 as you can. I'll go through and do my 56, which is kind of the brother to your 55. So for 56 part A, I need to shift the graph to the right one because the minus is inside the parentheses. For part B, the plus is inside the parentheses. That's going to move the graph to the left 2. Let me graph part A, but not part B. So I'm going to take each point and drag it one to the right, one to the right, one to the right. And I should get a graph that looks something like that. So this is f of x minus 1. And again, if you don't do every graph, I'm completely content with that because it's not particularly hard to move a graph left, right, or up or down. For part C and D, part C is going to move the graph down 1 because the minus is after the function notation. Minus is after the function notation moves the graph down. Minus in parentheses moves the graph right. The plus 2 in part D, since it's not in a parentheses, is going to move the graph up. Let me do part D. I'm going to take each point and graph it by moving it up 2, up 2, up 2. I'll get a graph that looks like that. So this is the graph of f of x plus 2. If I wanted to, I could do f of x minus 1 by taking each point and moving it down 1, down 1, down 1, and getting something like that. You can do as few graphs as you want, but you have to describe every graph. For part E, to describe, the minus inside the parentheses is going to move the graph to the right 1. The plus 2 after the function notation is going to move it up 2. For part F, the plus inside the parentheses is going to move the graph left 2, and then the minus after it is going to move the graph down 1. Let me do this graph. So I'm going to go left 2, down 1, left 2, down 1, left 2, down 1. I can't hardly do that graph so well. I don't think I can do it much better. I don't have another sheet of paper to fix it on. So I took each point, moved it left 2 and down 1, and then all of a sudden this point wound up on the graph, so I kind of, I don't know, I kind of am surprised by this graph. This is the best I can do right now. Maybe I can do this one better. Right 1 and up 2. If I did this one, right 1, up 2, right 1, up 2, right 1, up 2, and get something like that. That's f of x minus 1 plus 2. I don't think I did this wrong. The left 2 and down 1. I just am surprised by the graph. As long as I took every point and moved it to the left 2 and down 1, which I think I did correctly, and then connected something that has the same shape, I'm okay with my graph. Last problem for the section, the reflections. The negative inside the parentheses is going to reflect it over the y-axis. Takes each point and moves it to the opposite side of the y-axis. This point that's 1 to the right of the y-axis is going to move to 1 to the left of the y-axis. This point that's 2 to the right of the y-axis is going to move to 2 to the left of the y-axis. This point that's 5 to the right of the y-axis is going to move to 5 to the left of the y-axis, and the graph's going to go in the opposite direction. This is the graph for f of negative x. It's reflected over the y-axis, so you get a mirrored image over the y-axis. Negative f of x with the negative in front of the function notation is going to reflect it over the x-axis. It's going to move each point to the opposite side of the x-axis. The point 1, 2 is going to move to 1, negative 2. The point 2, 3 is going to move to the point 2, negative 3. The point 5, 4 is going to move to the point 5, negative 4. And that's going to be considered reflected over the x-axis. I think I did a better job graphing that than I did that, but yeah, they are what they are. As long as you do the right thing to each point, the graph I'll have to live with, even if your graphing abilities are on par with mine. Let me flip that 55 back up, and that's the end of the section, so I'll just end the section now. And the next section we get is word problems. They're not bad word problems, but I wouldn't jump into them right now. Give yourself a break before you jump into those.